Right, we're back. Hopefully you did okay on that one. So the solutions here don't really make too much of a graph. So what I've done is I've copied this into Desmos here, and you'll see here's my original graph that looks like the one in the textbook. And this is something that's kind of neat. Instead of saying y is equal to in Desmos, I wrote f of x equals this, and then here I wrote y is equal to the square root of f of x. So it remembers this function f up top, and then here I can just say do the square root of that previous function, and here we get our answer. So once again, the domain starts from -2 and goes to the right. Our two invariant points where y of the original function is equal to 0 and y of the original function is equal to 1. Those are common points, so when you graph that, you should make nice little dots to show that that's happening. And then the square root of 4 is 2, and I don't think we should go too much further beyond that. Looking at their solution as well, I think you have to state the domain and the range. So the domain is x is greater than equal to -2. Make sure you mark those 2 points. And then does it say the range somewhere? Let's see about answers. And then the range is y is greater than or equal to 0 again. The next example they have is a parabola. So if our original function is y is equal to x squared plus 1, here's y is equal to x squared plus 1. And now what happens when you graph the square root of that? Now it kind of just, on the surface of it, in this particular example, just kind of makes it wider. But if we follow our same pattern, you say, okay, the two invariant points are on the original function wherever y is equal to 0 and wherever y is equal to 1. We don't have a 0 example, but we have a 1 example. So we have one invariant. All right, and now whatever the values are of my original function, my values of my new function are going to be the square root of that. So if you can find here, this value is 4, so the square root of 4 is 2. So you can see how that lines up. Here the square root is, here's 9 from my original function, so this value is 3. So you can see that kind of effect. And again, they don't put arrowheads on the ends, but you should put them on there. So you can take a look at those examples if you'd like, so you can see how that changes. Looking at example number 2, they have us do some solutions. The first, some parabolas again. Looking at the first one, you're going to say, okay, now where are the invariant points? This is when in the original function you get a y value of 0. So here's an invariant point, and here's an invariant point. So in my new function, I'm gonna have 2 when y is equal to 0, and now when y is equal to 1, here's an invariant point, and here's an invariant point. So that's going to be common to both functions. So in green here, I'm writing in green my y is equal to the square root of f of x, and I'm going to remember how it works. It goes between 0 and 1, it goes over it, and then it goes under it. Okay, so we'll start off, we'll say, okay, I'm going to go over this. It's kind of hard to see. I'm going over this, and then afterwards I'm going to be going under it. So it's very hard to zoom in on that. And now I'm going under it is going to have a smaller shape, because whatever this value was, it gets square rooted. Well, this seems to be 9, right? Right there, that looks like 9. So the square root of 9 is 3. So the highest point here it's going to get to is 3. So it's going to go over the original function, and then it's going to go under the original function and get to here, and then again it crosses there, goes back. It's a really bad drawing, but that's as good as you're going to get from me today. So let's look at their answer. There is their answer, and I don't know if you can see it here. It goes over it and then it goes under it. I'm going to hide a solution, and then I'll get you to give it a try. Okay, so for 2a here, oh, this one's upside down and this one's so it's not quite exactly the one we looked at. To do this 2a1, you might have to look at example 2b first, but I'm going to ask you to do this one as well. I'll just pause it here, and then I'll show you the solutions for that. So